and good afternoon, CTS267, Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP route course, and this is going to be the final Cisco Learning Labs activity of the semester as we come to a close here in the final week. We've got the fourth and final troubleshooting scenario out of the Radulko limited network. So let's go ahead and dive in here and see what we are dealing with. All right, so we've got two issues that we need to resolve. So here is the first issue. That Marjorie noticed that the router DST has learned a bunch of external routes through OSPF. These addresses are in the public address space and, as far as she knows, do not belong to the Radulko Transport Limited network. So the route should not be seen on the DST router, that distribution router. We've got two IPs, and let me write these down for internet connectivity testing. 209.165.133, and then the 2001 DB8 0D::100. All right. So those addresses have been written down so that we don't have to refer back to them. And what does it say here? Yeah, we're going to have to go from the headquarters router and SSH over to the distribution router. So let's jump in and take a look at this first problem. So we're going to need the IP address for the DST router 10121. We're going to write that down as well. So let's start. We'll go to HQ2 because, as you can see, I'm trying to click here. We can't get there. So we come to HQ2. We're in user exec. Let's get into privilege exec, CISCO, and SSH-L admin over to 10.1.2.1. where we should, hopefully without too much delay, be getting a password prompt here. And then we'll get logged in and check. Now, as I'm typing this in, so if I'm seeing external information, right, external routing information, and we're on the DST router, so I'm going to say show IP route. And you can see, yeah, we're actually seeing OE2 routing information. Now, there's only one way that external information gets into the OSPF domain, and that is if it is redistributed into the OSPF domain. So that means that we're obviously, as you can see here, clearly running OSPF. Let's say show run, whoops, sorry about that. We'll say show run, pipe it to section OSPF or section router OSPF, and in fact, very interesting. So this is going to raise the level of complexity a little bit here. And specifically, I'm looking right here and below, because what do we see? So we're running OSPF v3 with address families. I think RFC 5838, if I'm not mistaken. So again, we're running, it's not OSPF v3 for IPv6, right? It's OSPF v3 with address families, which means that our transport for everything, both IPv4 and IPv6, is IPv6, right? Which means our v4 information is being transported via IPv6. So again, and this also changes the commands that we're going to end up running here, and I can actually demo for you. If I was to say show IP route OSPF, I think this might be one. Instead, what we should be saying is show IP route OSPF v3. Yeah, there we go. So, and this is one of the more frustrating things, right, is I want to see the IPv4 information. So I say show IP route, right, because that's going to show me the IPv4 information. But if I only want to see the OSPF information, if I say OSPF, that will work, right? But that will only work when we're doing ISPF, when we're doing OSPF with IPv4. When I'm using OSPF v3 with address families, we have to say show IP route OSPF v3 to see all of this external information that we're talking about. And you can see, where are we learning all of these prefixes from? This network layer reachability information, which is showing up over here on the distribution router as a type 5 LSA. If I were to say show IP OSPF database, am I going to see anything? No. But I've got IPv4 information here. Why am I not seeing it? Exactly. Show IP OSPF v3 database. And is it not OSPF v3? It should be show IP OSPF, or is it show OSPF? Hold on one second here. And this is what I don't like. OSPF v3? Yeah. Show OSPF v3 database. There we go. And so here's where we're going to come in, and we're now going to see those type 8 link LSAs and the type 9 intra-area prefix information here. And so here's my type 5. Sorry, I was looking for my type 5s. So here are the type 5s, right? But again, we don't say show IP OSPF database anymore. We say show OSPF v3 database to get the information. So again, this is sort of raising the bar in terms of the troubleshooting scenario. Now, interestingly enough, we have the default route as well here. So we're on the DST router again, and we've got that external information we need to get rid of, which means it must be redistributed. So if I was to say show run section router OSPF v3, there's no redistribution here on this router, which means, if we look here, that it's not going to be, so real quickly, we're not going to be running OSPF v3 on that connection with the service provider, right? Unless this is a PE router and this is a CE router, and even then we would preferably want to run BGP, eBGP, right? But we're probably not running OS because we don't want information internal from our setup here, OSPF information, to be shared out here with the ISP router, which means the redistribution's got to be taking place on HQ2, which unfortunately means we have to terminate this session here and go back to HQ2. So on HQ2, show run section router OSPF v3. And that is exactly the problem. We should see the problem immediately here when we take a look at this, right? Here's the address family for IPv4, and we are redistributing from BGP Autonomous System 65,000, that is us, into the address family for IPv4. Now, remember, we don't need the subnets command here, okay? Because, again, this is OSPF v3 with address family. So redistribute BGP 65,000, and we're redistributing that into OSPF. So this is where that information is coming from. So if I was to do this, let's clear the screen. Let's see what HQ2's show run section router BGP looks like. And so here is the BGP configuration, and it looks like we are doing multi-protocol BGP. And yes, again, so this is dual stack, straight up multi-protocol BGP. And remember, we've got these no neighbor statements here because we're not activating the IPv6 neighbors under the v4 address family. So again, it's not 6 over 4, it's not 4 over 6, it's 4 over 4 and 6 over 6, straight up dual stack. We've got our 2 activate statements here. Remember, in activity 19 or challenge 19, this was one of the issues, was we were missing the activate statement for one of the BGP neighbors. So we are redistributing information from this BGP autonomous system, which is ours, right? 65,000. That's our BGP ASN number. And so to fix this, we're definitely going to get, definitely going to get into global config, router OSPF v3.1, address family IPv4 unicast, no, redistribute BGP 65,000. Right? So that looks good there. Now let's go back over to, let's see, SSH-L admin and to 10.1.2.1. And let's see if that has taken care of the information that we see, that external routing information from OSPF, so CISCO. All right, so show IP route OSPF is going to show me what? Nothing, right. Well, show IP route OSPF shows me nothing. Show IP route OSPF v3, that's going to give me the information, and we still are getting this external routing information, which has to mean that it's being redistributed from somewhere. It's got to be HQ1. All right, so let's check HQ1 here and CISCO, and let's go ahead and say show IP route OSPF, but what are we going to see? Nothing. OSPF v3. There we go, and it doesn't appear that we're doing any. Are we doing any redistribution here? Show run section router OSPF v3. Oh yeah. Okay, so we're redistributing off of HQ1. I thought I would see more external information there. And oh, you know what? We pulled the redistribute. Okay, so I was looking here for OE2 information, but we're not going to see OE2 information because I pulled the redistribute statement off of HQ2. So, but we're still redistributing here, so we need to sort this out. So let's go ahead and say router OSPF v3.1 address family IPv4. IPv4 unicast, and then no redistribute BGP 65,000. Right? So that should ensure that we are not seeing over here on the DST router. All right, good. So that took care of the problem. Now, when we look at this architecturally, right, from a design perspective, what we had was we were redistributing information from HQ2 and HQ1 into OSPF. And typically, we don't want to do that, right? So the ISPs, what we should be getting, and I can quickly check this here, and we'll do it with the dots. We'll leave our drawings on there. Do show IP BGP. Are we getting a default? We are. Right? And so that's what I'm looking for. I'm looking to see, typically what happens is the ISP is simply going to give us a default route. So in addition to the default route, we've got this extra information here, but we don't need that. All we need to do from an OSPF perspective is to do a default information originate, right? If that's what we want. If we want the OSPF traffic to default to HQ1 and HQ2, we could do default information originate. We don't need to shove all of this external information into OSPF. Again, the BGP routing table, as of I think it was last week, is at 665,000 IPv4 prefixes. So if you want to put 665,000 OE2 entries into OSPF to provide reachability to external networks, don't do it. just say no. Don't do it, right? So typically from a design perspective, what we would do is the HQ routers would simply originate, default information originate the quad zeros into the OSPF domain, and then that gets the traffic here, and then again we default here. If we don't have a longer, more specific match, that traffic is going to go out to the internet via the BGP default route that we have, right? Okay, so a little design conversation there real quickly. Again, not sure why. I know it's for the trouble ticket, but again, not very popular to be redistributing external BGP information into OSPF, especially like in mass when we're talking 600,000 plus routes. All right, so that takes care of the first ticket, and now we've got the second ticket. So PC1 and PC2 are unable. So this is definitely going to be bottom up, right? You can see here we knew what router to take a look at to confirm things with our troubleshooting methodology. We knew they were being learned through OSPF, and that kind of led us down the rabbit hole to the solution. Here, and this again, this strong suspicion that the problem lies in the neighbor discovery protocol. As the solution, she suggests that the implementation of HSRP for IPv6. So to be clear, PC1 and PC2 are unable to access the IPv6 internet. Okay, so when I see this, I'm immediately thinking that it could be an IPv6 ACL, and in that IPv6 ACL, there's going to be a deny statement somewhere for the neighbor discovery that would allow us to get connectivity, if that's the suspicion. So let's sort this out. Let's go to PC1, and we'll start here, and let's confirm that we can't reach the internet, which is going to be ping 2001:db8:0:D:100. And so we get the ins back, right? So what does that mean? What if I said show IPv6 interface brief? So here's the problem, is I've got a link local address. I have no global unicast address. So this would be the equivalent of, and we've dealt with this before, right? So I've got a kind of a sneaking suspicion here that this is going to be this is definitely part of the issue, right? Where before when we said show IP interface brief, and it showed DHCP and no address, right? Which we were having issues with DHCP, or we're in the wrong VLAN, or whatever the case may be. But again, we're not getting a global unicast address. And so this stands to reason that we can't, well, there's no way we're going to get out, because that is a link local address. That address is germane, right, to the local link. We can't go outside of the local link with that address and hope to get out to the internet and then get back. Not going to happen. So she thinks it's the neighbor discovery protocol, and she wants HSRP v6. So let's come back to this router here. Whoops, and we'll say in. And let's say show IPv6 interface brief. What do we have here? All right, so we're still doing the router on a stick. But that's the thing, is flipping to HSRP for IPv6, that doesn't solve me not getting an address. HSRP for IPv6 would provide gateway redundancy, right? That first hop resolution FHRP redundancy, but it's not going to get me an address. So is there show IPv6 access list? So is there an access list on one of these sub interfaces? And lo and behold, man, they got all kinds of stuff going on here. IPv6 ACL v100. So those are all OSPF v3 related. Are any of them tied? Let's just do a show run here real quick. And to get to the interfaces, the sub interfaces in particularly here. Excuse me. And so what I'm looking for here is to see if any of these IPv6 ACLs are applied to the sub interfaces. And we are running IPVRRP, so that might turn out to be an issue anyway if we try to run HSRP for IPv6, because we have VRRP running for IPv4. Okay, OSPF v3.1, so the OSPF statements are on here for 10 to 100. All right, let's compare and contrast. I'm going to take a look at HQ2 here. And let's see, whoops, let's see what we've got going on. Oops, on HQ2. We'll get into privilege exec. And I want to see the interfaces again. Oops, sorry. See the interfaces again, and here we are. And the suspicion is it's something to do with neighbor discovery. So what is interesting is, and this was the problem on... yeah, so you can see we've got the OSPF v3 1 IPv6 area 0 commands here. We don't have any of that. We don't have the... We're missing these commands on all of those interfaces. Now, that's IPv4, and that's not causing the problem we're having here. So there's no IPv6 ACL on here that's blocking the neighbor discovery protocol. And why are they choosing a /69? And is it a 69 over here as well? It is. Okay. So I'm going to leave the OSPF v3.1 IPv4 area 0 commands out of the equation here, because it's very possible that that is not, I don't think that has anything to do with our issue. HSRP for IPv6 is not the solution, and it's got to be that it's a /69. And is that because... So if we're not doing... there is no DHCP v6. And I wonder if it has to be... So if we're not doing DHCP, it's got to be that that needs to be a /64. Let's see if that's fixed. Okay, so now, really not shoot from the hip. So now I'm basically going to make a change here that I think is going to resolve things. And interface, what's that interface where the /69 is at? 00.10. Interface, Ethernet 00.10. And we're going to say no IPv6 address. And the reason I'm saying no IPv6 address is because if I were to put another command in here with an IPv6 address, it might allow it to go in there. Then we'd have multiple commands, but it may kick it back and say it's overlapping. But we're going to do this. We're going to say no IPv6 address 2001:db8:0:A0. No, that's wrong interface. A0 10::2 A010::2/69, and I'm going to rerun this command. And again, hoping do show run interface Ethernet 00.10. Okay, so now through neighbor discovery, if I go into... And I don't need to go into global config. I should pick it up automatically here. Show IPv6 interface brief. Interface brief. No. All right, global config, interface, Ethernet 00. Let me shut it down. And then we're going to do a no shut. And do I have Ethernet 00, IPv6, sorry, do show run interface, Ethernet 00. Okay, so IPv6 address autoconfig is on there. So now we're going to say no shut. State change to up. Okay, do show IPv6. Okay, good. We got the v4 information from DHCP. Yes, there it is. So it was the fact that it's a /69, and if I'm not mistaken, I would have to check on this, but I don't think that you're going to get an address. And what I'll actually pull the solution up here, because I'm very curious about this, because I think that it would be that it's not going to work unless it's a /64, but I don't know if if it's a 64, if it just, yeah, it's got to be a 64. So let's get into interface Ethernet 00.10, and we'll do the same thing here. No IPv6 address, 2001 colon db8 colon 0 colon A01010 colon 3/69. We'll pull this back up. We'll make it a 64. And this will be the luckiest I've gotten in a while here if that turns out to be the issue. So we're changing it to /64s. Let me go ahead. We'll check out PC2 here. Show IPv6 interface brief. And we've got it. So can we ping out to 2001 colon db8 colon 0 colon delta colon 100. All right, so that solved it, and I'm going to pull the answer key up. I typically don't do this, but I'm going to pull the answer key up because I'm curious what it says. Okay, so it's SLAAC. It's not neighbor discovery. So stateless address auto configuration will only work if the router's IP has a prefix of /64. Has nothing, yeah, has nothing to do with the neighbor discovery. Yeah, because I thought it would be maybe there was an IPv6 ACL. That clearly wasn't it. So it's that SLAAC, not neighbor discovery, but SLAAC will not work if the router interface is not a /64. And the suggestion from the customer that HSRP for IPv6 is misleading. No kidding. Okay, well, this brings to a close the Cisco Learning Labs activities for the semester. And again, love learning stuff. Great way to learn things. And man, got very, very lucky there on that /69. So it's stateless address auto configuration will not work unless it is a /64 on that router interface. So good to know. And then we saw that we were redistributing information into OSPF v3 with address families, and we had to get in there and sort that out. All right, well, that is it for the spring 2017 semester. Thanks so much for watching. I will see you guys tonight.